Exercise 7.1, question number 6. Name the type of quadrilateral formed, if any, by the following points and give reasons for your answer. First question, 4 points are given. Let A, first one, second one you can mark by B, C, D, be the vertices of the quadrilateral ABCD. Now find the distance between A and B. A point -1 -2, B point 1 0. Therefore AB equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Put the value for x2, x1, 1 minus minus plus 1 whole square, 0 minus minus plus 2 whole square, 2 square plus 2 square, 4 plus 4 root 8. Factor 2 2 2, 2 root 2 units. Same way, find out distance between B and C, distance between C and D, distance between A and D, all will be same. Then diagonal A and C, because diagonal also we are going to check since all sides are equal here. AC equals to square root of x2 minus x1 whole square plus y2 minus y1 whole square. x2 minus x1, so minus 1 minus minus plus 1 whole square, 2 minus minus plus 2 whole square, 0 square plus 4 square, root 16, 4 units. BD also we are getting 4 units. Since all sides are equal, diagonals are also equal, it is a square. Now second question, these are the points. Select A, B, C, D be the vertices of the quadrilateral ABCD. Now find out distance AB, same formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square. On the top you mark x1, y1, x2, y2. x2 minus x1, so 3 minus minus plus 3 whole square, y2 minus y1 whole square. 6 square plus minus 4 square, 36 plus 16, root 52. Find the factors for this, then it's coming out 2 root 13 units. Then B and C, we are getting this. Distance between C and D, getting this. Distance between A and D, we are getting this. Since all the distances are different here, we don't need to check the diagonals. Write down AB not equals to BC, not equals to CD, not equals to AD. So ABCD is not a particular type of quadrilateral. We can't give any specific name for this quadrilateral. It is a quadrilateral but not a particular type. Question number 3, do it by yourself. You can try. Question number 7. Find the point on the x-axis which is equidistant from this and that. On the x-axis we can select the point x, 0. Let P x, 0 be any point on the x-axis which is equidistant from the points A, first one, and B, second one. Therefore AP equals to BP. Both side distance formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square. Which alphabet first? You mark x1, y1. Which one second? x2, y2. So x2 minus x1, that is x minus 2 whole square plus 0 minus minus plus 5 whole square equal to square root of x2 minus x1, that is x plus 2 whole square, y2 minus y1, that is 0 minus 9 whole square. Now to remove the root from both sides, we can go for squaring. You don't need to show anything, just write inside the bracket by squaring and root will go away. Then a minus b whole square formula, a square minus 2ab plus b square plus 5 square is 25. Here a plus b whole square formula, minus square plus 9 square 81. Different side, same thing, same sign can cancel. Because if positive goes there means negative and ultimately it will be cancel only. So different side, same number you can cut with same sign. These two also cut. Now minus 4x, this you bring this side. Minus 4x becomes minus 8x. 25 goes there means 81 minus 25, that is 56. Therefore x is equal to 56 by minus 8, which is coming out minus 7. Therefore required point on the x-axis is minus 7, 0. Now page number 168, example 6, same like this question number 7 only. You can try by yourself. Bye.